In September 2025, an MCP server on NPM called Postmark MCP. It shipped a new version that is 1.0.16. It looked like a routine update. It added exactly one behavior, but a silent BCC that sent a copy of every email to an address the attacker controlled. So roughly it has 15 downloads per week, and until security researchers caught it. So here is the uncomfortable part. We test our UIs and we test our APIs. Then we integrate AI agents into production through these MCP servers where most of the teams have never tested at all. So in the next few minutes, I'll break down the 4 layers of testing an MCP servers actually needs, the official tools that already exist for each layer, and my honest answer to the question almost nobody is answering, that is, who will actually test these MCP servers, like who is responsible for testing them. If you are an SDET or an automation engineer, I think this is the biggest new testing surface since REST APIs took over. Alright, so let's start understanding what is an MCP. An MCP stands for Model Context Protocol, which is an open standard started by Anthropic in late 2024 that gives an AI agents one consistent way to call the external tools. A server exposes tools, resources, and prompts, and the agent discovers them and calls them. And there are thousands of servers already in production now. So big companies like Stripe, GitHub, Notion, they ship their own official MCP servers. And of course, your company may already be running a few, whether you know it or not. Now, if you search MCP testing today, you mostly get videos about Playwright MCP, using an agent to test your website. That's agent testing for you, and I'm asking the opposite question. Who tests the MCP server itself? And most of these SDETs might be thinking that it's just a JSON API, so our traditional API testing habits would transfer. But that is not 100% true, because there are 3 reasons. So here is the reason 1. Your caller is not deterministic. With a REST API, the client is simply the code. Same request, same behavior. But with an MCP server that gets called by a large language model like an LLM that decides based on your tool names, your descriptions, and your schemas. And it also decides when and how to call, which leads to the reason number 2. So in the reason 2, the tool descriptions are not documentation anymore. They are the actual behavior. In 2025, a couple of researchers demonstrated that how can you add some hidden instructions inside the tool's description that the model obediently follows. So basically at this point, your docs are now your attack surface. And the reason 3 is the protocol itself. Because it's a new protocol, so it is moving fast. The revision that landed this July made the protocol stateless and changed error codes and deprecated some features. So every revision is basically a regression risk. So if the protocol specs keep on evolving or changing, then your MCP server does need to adopt those changes. That means you have a high chances of regression risk. So you need to continuously evaluate and test your MCP servers, tools, descriptions, as well as the schemas continuously. So here is the testing stack I would actually build. It has 4 layers. So let's start with the layer 1. The layer 1 is talking about the protocol conformance itself. There is now an official conformance suite. So one command pointed at your server with scenarios for the handshake, tools, resources, and auth flows, plus a simple GitHub action so it can run in CI/CD. Now the layer 2 is the tool contract. So here we are going to test every single tool that we expose part of the MCP server. So we need to send the valid inputs, invalid inputs, right? And then the missing arguments by performing the congruent calls to those tools, and of course the error responses. And you don't need a LLM or a model in the loop to test your MCP server. The current SDKs, they ship in-memory transports. So a real client and your real server run in one process, and the whole suite finishes in just milliseconds. Now let's talk about the layer 3, the security layer, which is very important. So there is an official MCP security best practices document. So it covers the token pass-through, the server-side request forgery, and then the state handling hijacking, tool poisoning, and so on. And these are not just theory, guys. There are real incidents happen in the production. Like for example, path traversal in file system servers, a remote code execution chain in a Git server, and a prompt injection through the GitHub issues. Alright, so here is the last layer, that is evals. This one is a little bit strange for us. So your server can pass every test I just described and still fail in the production because your model can't figure out how to use your tools. Let's say there is a vague description or an ambiguous parameter name that makes your task unsuccessful. So Anthropic's engineering team recommends building a set of realistic tasks and measure the completion rates. Now you can notice the shift. Pass rates and thresholds, not the green check marks that we generally used to get in our traditional testing. And that testing is deterministic testing. But this testing that we'll be doing, part of the evals, is the non-deterministic testing. So this is totally a new muscle for most of us. Alright, now whose job is all of this? The honest answer is it's a shared responsibility. But let's be more specific when we say about shared. Who is going to take care of what layers, or who is going to own what layers? So let's start with the devs. Devs are going to own the layer 1 and the layer 2 because the conformance and the contract test sits next to the unit test cases like any other service. And then the layer 3 is going to owned by the security engineers because that is their craft and their expertise in performing the security testing than the regular traditional SDETs. But somebody has to own the whole thing as a quality problem. So somebody has to take care of the regression strategy, the CI wiring, the eval baselines, and of course the release gate that says this server is safe to ship. And that is, in my opinion, as a quality engineer, that owner should be the SDET. Because we already do a lot of automation and we already think in contracts and schemas. So the only genuinely new skill in this stack is evals. And it's learnable, it's achievable. So if someone is building an MCP server, they still want a test partner on that harness. And if you are an SDET wondering whether your skills still matter in the AI wave, so this is a surface almost nobody owns it. So my recommendation here is, as an SDET, if you want to sustain in this new AI era, then evals and testing the MCP servers is what something which you need to upskill and need to look into. Alright, so here is the starter plan that I would recommend if you want to cover the MCP testing by following these 6 steps. So first, let's list out all the MCP servers that your team is building or consuming. And number 2 is spend an hour in the inspector on your most critical server and hammer those edge cases. And next, write some in-memory contract test for your top tools that are exposed from the MCP server and put them in the CI. And number 4 is conformance testing. So let's have your conformance suite run nightly with a baseline file. And number 5 is security best practices. Refer to the MCP's official security best practices and turn those best practices into the test charters. And number 6 is write a few realistic eval tasks and track the pass rate. Treat the tool descriptions like the versioned API contracts. A one-line wording change can also change the agent behavior. So it deserves a proper code review exactly like a schema change. So the lesson is very simple here. MCP servers are production interfaces and they deserve production grade testing. As SDETs, this is totally new to us. And let me know if you have any questions or share your opinions or thoughts in the comments. Alright, so that's all for this video and I will see you in the next.